Hey guys, welcome back to the channel. I am Satyam Dhiman. I'm the student of BTech Computer Science. So today I am here with you all with the all new topic that is Q. So let's just discuss about it and then we will do some questions on it. So first of all, we come here to know that what is Q. So a queue is a fundamental structure in computer science that follows the FIFO principle. That is the first in, first out. Means the element that is added first will go first out. So in a queue, elements are added at the one end called the rear, and they are removed from the other end called the front. Okay, so we can also take an example like if you are just standing in a line, like a real life example, like you're standing in line. So as you can see that the person who is in the front, he just leaves the very first means the like I'm just standing in the front. If my work is over, then I will the first one to just get out of the queue. So here that what the queue means. So here we are with the some questions that are first question is implement a queue data structure in a preferred programming language which has all the basic functionalities. And the second question is reverse the first k elements given a queue and integer reverse the first k elements of the queue. The remaining elements should remain in the same order. So let's do these questions. So here I have opened my interface. So here I'm gonna work with the Python to do these questions. So let's just do it. So first we will just create here the class that is queue, and then we will just define a function here that is the self, and the self dot items equals to empty braces. Then again we will define a function that is this empty return length of self dot items 0. Then again we will define a function that is enqueue self of item, then self dot items dot append dequeue of self if self is empty, then raise index error dequeue from empty queue. Then again we will define a function that return self dot items of pop. Then here we will again define a function that is peak as self is empty. Then we raise index error peak from empty queue. Return self dot items of 0. Then we will define size of it and we will return length of the items. So this is a basic program of queue in which all the basic functionalities are just given. So here we will just go with the example. So let's just do example here. If name underscore equals to main, then q equals to q of empty function q dot enqueue equals to 3 print q size output from print dq output print peak So here is the following example of this code. So let's just run this code. Yeah, so here you can see that the queue size here is 3, DQ size is 1, and the peak here is 2. So let me just explain this code to you. This implementation includes the following basic functionalities. Here the init initializes an empty list to store queue elements, is empty, checks if the queue is empty or not. Enqueue adds an element to the rear of the queue. Then dequeue removes and returns the element from the front of the queue. Then peak, here the peak element returns the elements from the front of the queue without removing it. And size returns the number of elements in the queue. So this was our first question. So now let's move on to the second question. I think our second question was, yeah, reverse first k elements. Okay. So first we'll create a class here. Then we define a function in it that is self, and then we will self dot items equals to is empty, return length of self dot items equals to 0. Define enqueue self of items, then define dequeue of self. If self is empty, erase index error dequeue from empty queue. Return self dot items not pop. Then define size of self. Return length of self dot items. Then define reverse of k elements. If k is less than equals to 0 or k is greater than self of size, then return stack equals to empty. Push the element first k elements of the queue onto the stack. For I in range, stack.append self.dequeue, pop the elements from the stack and enqueue them back into the into the queue. While stack self.enqueue stack.pop, then rotate the remaining elements in the queue by k positions. For dash in self dot size minus of k self dot enqueue self dot dequeue. So this is the particular code for returning the k elements from the queue. So let's just write down the example also, and then I will just explain the code to you. Example: if name equals to underscore main, queue equals to queue empty stack, then populate the queue for I in range 1, 11, and then queue dot enqueue of I, print original queue as queue dot items, then k equals to 5, q dot reverse k elements, print q after reversing first k elements. Right. Yeah, so this is the following example. So now let's see if it's working or not. Yeah, so here you can see that the original queue was up to 1 to 10, and queue after reversing the first 5 elements, that is uh, from here, that is a 5 came in front, 4, 3, 2, 1. So basically this code first dequeues the first k elements from the queue and pushes them onto a stack. Then it dequeues elements from the stack and enqueues them back into the queue, effectively reversing the first k elements. Finally, it rotates the remaining elements in the queue by the k positions to maintain the original order of the queue. Then it just adjusted the value of the k and the elements in the queue to different test scenarios. So this was the particular code for just reversing the first k elements. So I hope that these both the codes were just clear to you. So now we will just here discuss the another topic also, which is on the linked list. So basically, what is a linked list? So linked list in a linear data structure consisting of a sequence of elements called nodes, where each node refers to two main components. One is the data and other is reference to next node in the sequence. Linked lists are used in various applications and are particularly used when the size of data structure is unknown or when the frequent insertions and deletions are required. So here we will just do some operations on the linked list. So these operations are the first we need to just create a linked list. Then second, we need to just insert the functions into it, that create a function to insert a node at the beginning of linked list. Third, create a function to insert a node at the end of the linked list. Fourth, create a function to insert a node at the middle of the linked list. And then we'll perform the delete operation, and then we perform the traverse operation. In delete, there's a create a function to delete a node from the beginning of the linked list. In another, it is create a function to delete node from the end of the linked list. And last, it is a create a function to delete a node from the middle of the linked list. And last is the traversing. That is a create a function to display all the data stored in the linked list. So let's do its question. So let's just do its operations. So here I'm using Python, or you can also use just different languages to do this. So first we'll just create the class node. Then we will define in it the self of data. Then self dot data equals to data. Then self dot next equals to none. Class linked list. Then define in it self. Then self dot head equals to none. Then insertion operations, define insert at beginning self of data, then new node equals to node of data, then new node dot next equals to self dot head, and self dot head equals to new node. Then define insert at end self of data, then new node equals to node of data, new node if not self dot head, then self dot head equals to new node. Return current equals to self dot head, while current dot next current equals to current dot next equals to new node. Then define insert at middle self of data positions. Then if position equals to 0, then self dot insert at beginning of data. Then return a new node, that is node of data, and current equals to self.head for underscore l range of position minus 1 if current is none, then raise value error position out of range. Then current equals to current dot next new node equals to current dot next, then current dot next equals to new node. So this was the program for the insertion operations. Now we will go for the deletion operations. Define delete at the beginning of self if not self dot head raise value error list is empty, then self dot head equals to self dot head dot next, then define delete at end of self if not self dot head raise value error list is empty, then if not self dot head dot next self dot head equals to none, then return current equals to self dot head while current dot next equals to current is equals to current dot next, then current dot next equals to none. So this was the program for the deletion operations. Now one thing is left, then delete at the middle element if position equals to 0, then self dot delete at beginning, then return current equals to self dot head for air dash and range position 1 if current is none or current dot next is none, then raise value error position out of range, then current equals to current dot next equals to current dot next. So this was the code for the deletion operations. Now we will do for the transverse operations. Transversal operations. Define display self current equals to self dot head while current print current data equals to current dot next and print none. So this was the code for the insertion operations, deletion operations, and the traversal operations. So now let's do an example, then it will be more clear to you. Name equals to under mean, and then create a linked list. Linked list equals to linked list. Insert elements. Linked list at the end. Linked list at the end. Then display elements. Print linked list after linked list. Then we will insert elements at the beginning. The beginning 5. Print list after insertion at the beginning. Then linked list dot display. Then insert at the middle. Linked list at middle. 15, 2. Print linked list after insertion at middle. Then delete elements. Linked list element at the beginning. print linked list after deletion at the beginning, then linked list display, linked list delete at the end position, linked list after deletion at the end, linked list dot display, then linked list at the middle of the print linked list after deletion at middle, then linked list. So this was the code for the inserting the element, for displaying the elements, then and deleting, and for the traversal. So now let's check that if how the following code is working or not. Yeah, so here you can see that the linked list after the insertion was at 10, 20, 30, none. Then at the beginning it was 5, 10, 20. At the beginning it's showing the means the element at the beginning. Then the linked list after the insertion at the middle, it will show the middle element and at the beginning, and at the after deletion at the end, means that when the element is deleted. So basically this code defines a node class to represent individual nodes in the linked list, and a linked list class to manage the list and perform operations. It includes methods for insertion at the beginning, end, and the middle of the list, deletion from the beginning, end, and middle, and traversal to the display all elements in the list. So this was all about the that queue and the linked list. I hope that you got that how to just do the program or how to perform the basic functionalities in the linked list and in the queue. So this was all about the video. Thank you guys.